Hello, folks, and welcome to our session. The Self-Healing Applications Decade is here. I'm your host, Anirban Chatterjee. I do product marketing here at Sonar, and I'm very thrilled to be joined by Boris Paskalev, who is the co-founder and CEO of LogicStar, which builds a decision engine for production reliability. Prior to running LogicStar, he co-founded DeepCode, which was one of the first AI systems for large-scale code analysis that was later acquired by Sneak. Boris, welcome. Thank you for joining us.
Welcome. Thank you, Anirban, for the introduction.
Of course. We're really excited to have this conversation today about why engineering managers need a decision layer to help them prioritize the work that they and their teams do. Before we get to that, I do want to just quickly talk about your background and what you're coming in with. Can you talk a little bit about what you're working on these days?
We're building on top of what we already started with deep code back in the days. So today we're seeing AI already made it kind of dramatically easier to write and ship code by far, right? And tasks are completed much faster. PRs are created in minutes. But something that's kind of all the AI labs did not actually focus on accelerating at the same pace has been exactly the decision making that you mentioned. And exactly, engineering managers pretty much no longer actually constrained by these coding speeds, but they're actually facing this constraint by prioritizing clearly what has to be actually fixed next. And in reality, what should not be fixed.
Thank you for that. I feel like we're getting a little ahead of ourselves. So let's maybe back up a little bit and talk about why this is such a problem and what the pain point is. Because one thing that we're seeing that you and I have talked about is that there is evidence that while development teams are actually getting faster and more productive and completing their work more quickly, they're also seeing increases in pull request review times, in code churn, and in issue volume. When you've seen this in your work, what is driving it?
Yeah, and that's exactly where the paradox actually begins. There is so much data out there that we have seen that the optimized velocity has been the main focus, and we have achieved it. I mean, pull requests numbers are growing through the roof, like more than doubling the amount in some people every month or every 3 months, which is crazy. But we haven't actually optimized for the decision quality, what we actually have to work on, right? So this is kind of the secondary part that we've seen at the very beginning of the AI generative code capabilities, that all the speed and velocity actually comes in with the cost, right? Where the kind of the review times have increased, the actual number of lines of code that are producing those pull requests have more than doubled. Code duplication, code stability, all of these have actually been impacted negatively, right? And this is kind of the duality, right? So the problem is not exactly kind of where you're getting the signals for all those problems, but actually deciding what really have to be fixing to maintain that balance, right? Because if you just fix everything, then likely you're actually building up a lot of tech that sooner or later will come back to bite you.
I was about to say the tech debt seems to be the biggest outcome of that, right? Because if you're just fixing problems that aren't worth being fixed, you're just kind of spinning your wheels and creating more problems down the stream, right?
Yeah, so that's exactly, you have to figure out where to draw the line and the right balances, right? More AI generates more code creates more duplication tech debt, that creates even more signals, and that actually makes the decision what to fix even harder, right? And this is where exactly we're trying to focus on.
Yeah, is this why development teams often struggle with finding the space to innovate? Because they're stuck in this maintenance loop?
Yeah, that's kind of the trade-off of timing. I mean, developers definitely feel very fast and productive, but then they're actually stuck of actually keep on fixing more things. And we've seen kind of the number of bugs per developer have actually increased substantially as well very recently. So that is right. Indeed the challenge.
You would think that they'd be able to handle this by just having a bit of discipline around the way they manage their backlog, right? So that's the part that's failing, I take it.
Yeah, indeed.
So can you talk a little bit about that? Like, why is backlog management so hard, especially in this current environment?
Yeah, it is a good question. So the backlogs in general, they actually capture a specific intent. What do you actually wanna fix? They don't usually talk about the impact that is there, right? And this code generation acceleration, as we spoke about it, pretty much, the detection is also in a way automated, right? We're not actually shy of signals, right? On the bottom of the layer, as I show on the slide here, we actually said, okay, we're generating code, that's great. We're able to run it, that's great. And then things like Sonar finds things, Sentry identifies observability things. Those things are also automated. We've been having those signals actually for years, right?
Right.
And most engineer managers that we actually speak to, they're not worried. They're not worried about the backlog. They're actually worried about what's actually hidden in those signals that they don't have time to look at. Actually, some research a couple of years ago, I think, mentioned that more than 90% of all the production incidents that happen are actually already had a signal, either in a scanner or a production system, or there's something in the backlog tells them, hey, that's a problem, it has to be fixed. But we either did not have time to work on it, or we just ignored it, right?
So there's a noise, there's signal to noise issue. It seems like there's all
That
these
is
signals that are
correct.
coming in. They have
Yeah.
difficulty even seeing them in time, or the difficulty prioritizing them to find out what to work on.
Yeah, so those backlogs, they were never designed to actually understand and collect all this evidence. They're all about, and when this happens, pretty much it's up to the engineers, manager, or even product managers sometimes to kind of go and collect this evidence before they can decide and send it to engineering. I
Right.
think I've heard teams pushing that all the way up to the customer success people on the phone, that they have to go and pull things from observability system before they can send it down to the engineering, just because engineers don't have time to deal with the volume.
Exactly. And all of this, everything you described, these sound like problems that they're not new, right? I think development teams for 10, 20 years have had these problems, but AI, I think, has really remixed the impact these problems can have, right? There's a greater volume of code being written. There's a greater velocity of code being deployed. Does that amplify these issues?
Obviously, what you're having on the scale, on the bottom, you're increasing the velocity and the scale by orders of magnitude, right? But then the prioritization on top remains manual, right? This really creates a chaos at the end of the day, right? So it's I'm seeing more and more engineering managers gaining more gray hair because they have to deal with that.
Yeah. And are there additional signals that are coming in because of the AI? There's way more AI tools that are also being used, right? The ecosystem is expanding dramatically. And I'm
That
wondering if there's also an increasing signal to noise issue just from that alone.
that is correct. Also, in addition to the acceleration of actually the creation of new things, there's also new tools that are giving you more signals. I mean, there's also capabilities of cleaning up signals. Then you are
Right.
asking, are you actually getting rid of them? But the idea is how do you actually end up correlating multiple of them, right? So if we look at this, this is called the compression of the signals into one kind of looks like. For example, I actually put one example here that you have multiple Sentry issues, kind of a Jira ticket, right? Then a pull request was correlated, it was old, and then that shows you the impact that it's there and who was actually responsible for it. And all of this kind of gives you not a single rank decision, but kind of the engineering managers kind of doesn't see just the alerts, but they actually see what really has to be fixed next, and they have the full evidence up and down the chain so they can explain that should be worked on because it impacts that many customers, the engineers have all the context they need, etc.
Right. Is code quality and code security like part of the signals that are being collected and compressed here?
Absolutely. I mean, the amount of signals, I think this is, as you mentioned, with the new tools will be exploding, but
Right.
any signal you can be getting, a lot of those signals are actually purely coming from customer success, from actually
Right.
scanners, from productions, from the code and how the code has evolved over time. We're now having some specification, agent.md files, the number of signals actually will be exploding over time, I think, and this is the reason why engineering managers alone cannot deal with that, right? Kind of in the triage meetings, everybody comes up with their own view of the universe and what's important, right? But actually putting everything together and finding some kind of a union to decide what it is, most likely, if it's done by humans, we will come up with local minimums, right? Rather than finding an optimal solution.
How does reliability figure in? Because I think one thing that I know you've talked about is treating the production reliability of the team as a competitive strategy to actually gain leadership that way. How does reliability work into this model?
It's a good question. Reliability is not just about actually avoiding outages. A lot of people think about like SREs because this is where the reliability comes from. But
Right.
reliability is actually protecting the roadmap and the time for actually building new things, protecting the engineering time, lowering the complaints that you actually have from customers, which a lot of companies has as part of their OKRs, getting rid of the repeat investigations that are happening after a release, improving the mean time to resolution, having much more stable things. So a lot of them are kind of active and proactive. And this kind of really changes the dynamics of a company, right? So once this is actually get put into production, the question is how do you make them operational, right? Everybody understands that it's needed, but we're kind of stuck into the reactive part and firefighting, and we can never kind of move away and really impact those core OKRs in a way that that customers ultimately benefit from and the companies themselves.
Yeah, I'm getting a lot of deja vu right now because in a prior life, I worked in IT operations, and one of the solutions that we worked on is actually doing something very similar for IT operations events, right? Where you'd have all these different monitoring and observability tools like an application monitor or a network monitor or an infrastructure monitor, and you'd be getting all these events that you would need to correlate together and bundle together to compress the noise, exactly like you're describing, right?
Yeah.
To provide something that can actually be a decision point for the IT operations team. So there's a lot of parallels between that world and what you're describing here, where a developer just needs to have like a contextualized set of signals that allows them to have a holistic view of what the actual issue is that they can then, point resources at solving, right? There's
Yep.
a ton of, I think there's still probably opportunity at the front end of this to make sure that the cleanest signals possible are making their way into this engine, right? I know SonarCube, for example, we spend a lot of time on making sure that our false positive rate is extremely low, like around 3%. And that's something that helps the signal to noise ratio. But I think when you start to correlate with other sources of data, like Jira, like you have here, for example, or Sentry, then having a good signal to noise ratio up front really helps with that, I would imagine, right?
I mean, absolutely, right? As we know, it is if you put bad data on the inside, right, bad data will come out at the end. So the cleanest possible inputs are actually always the best.
Right.
Unfortunately, with AI, it's not always the case. As you mentioned, the new AI tools, they are not highly predictive. They're not repeatable. They could be much noisier. And that actually provides more noise. So figuring out how to clean that up is also important. But yes, having pristine data is always the best.
Do you also see opportunities for teams like in different parts of the organization to have like a unified view of reality, like the security team and the development team, for example? Because each team kind of uses their own set of tools, right? But if they all
Yeah.
feed into the same matrix, does that help them get a common set of visibility?
In general, yes, because ultimately the goal of the company is the same, right? They want to have a stable product, then the customers could be happy, they could be profitable, etc. So
Right.
when you start from this kind of highest level kind of first principles for the companies, right? Then you go down and they'll actually trickle down into each functional organization, right? And having the same view and being able to understand when a developer works on it, if they actually have all the information why that's important, they are as if they're having the product manager next to them and explaining all the questions they would otherwise go and ask them, right? And same thing for the security, right? If you have the security person understand, hey, that's there. And by the way, I'm actually seeing that a customer over the past week was hitting exactly this endpoint, right?
Right.
So if they would just put the input that they created there, they would actually been exploiting that vulnerability. So it's not some kind of very theoretical one. People are actually knocking on the door, right? If they knock a bit harder, the door will just fall down. So you know that that's important.
Absolutely. So once you've got this visibility, once you have all these tools feeding into a common sense of reality, the next step is probably adding automation to the mix, right? As we move towards this automated SDLC, how does the role of the developer change in this environment?
Yeah, that's the billion-dollar question. I think everybody from the industry and outside the industry has been asking this for a while, right? The idea is that I don't think that the tools will kind of replace people per se, right? At the end of the day, I mean, people will be there. They're just going to be doing a different type of job, right? They will.
Yeah.
We already said they're not going to be writing as much as code, or I mean, they will be directing the code to be written, but they actually have to own the decision authority on top of it, right? Because code's going to be created mostly by AI. There's almost no doubt there, right? So developers should receive kind of clearly scoped issues at this point, right? Not the classical, like just, hey, something is crashing, figure it out, right? You're actually going to have all the information that is there. And based on this high level description, is going to be evidence-backed context being pushed directly, and then they can work on it. But that's, in a way, humans will not be the one filtering the noise, right? They should validate those high-level impact and decisions. For example, auto-fixing without prioritization increases the risk of regressions. We already talked about it, right? Fixing everything is dangerous. So the humans will have to kind of draw those lines, saying, hey, how much do I want to go there versus how much I can trust the system that it will not generate more tech debt, as we highlighted much earlier.
Do you see a system like this actually influencing automated decision making, where like the system itself actually decides how to fix a problem, or do you always see a human being in the loop?
We already see that for small problems, right? I mean, it's updating a library that doesn't change the signature.
Right.
Almost everybody does that, right? I actually see a number of companies that actually have moved away of actually having 100% pull request reviews by a human. They said, we just do it like this, we want to monitor it. They do it randomly as well, as they're learning, right? Figure out when they should do it and when not. But that's part of the velocity, right? You cannot apply 100% code review. So in a way, think about it like reinforced learning. Over time, we'll figure out, hey, in which cases the human did not touch it, in which cases they actually touched it, right? And then you slowly will be able to say, hey, there's an extremely high chance that this type of fix in this type of the code, nobody will ever change it. Nobody will ever want to touch it. While, obviously you have to change databases, you have to re-architect things. Clearly, a human will have to be involved.
Yeah, I think it's super important for the human to be in the loop, especially for these like high criticality decisions that have to be made. But also, the humans need to have the space to make those decisions. They can't be overwhelmed and overloaded as they do so, because then they'll decide poorly. There was something in the news just a few days ago, like Amazon actually empowered an AI to actually take down a service pretty recently. And that was a situation where, if I read correctly, what happened was the developer that was in the loop to review the decision had more permissions than they thought the developer did, and the AI actually used that developer's permissions to do things it wasn't actually permitted to do. That's the example of the kind of thing that can occur when you don't have like these guardrails in place to help the human make the right decision, but also make sure that bad things don't happen if the human occasionally messes up. I think this all fits in the same framework, right?
Yeah, no, totally makes sense. And kind of stories like this, and everybody gets scared about kind of AI coming and kind of destroying the world. And I think there's going to be a whole new category of things coming, is more of a automated compliance and auditing, right? Because right now this is more of a kind of, I'll say you do it every 3 months, every year, etc. But in the meantime, an AI got more permissions and could destroy things. So it's nice to be able to continuously monitor that as well. So I'm actually looking forward to see more in that direction as well.
Me too. Yeah. So as we're trying to help developers and their leaders make the best decisions possible, like what steps can an engineering manager take to help their teams reduce noise and focus on where they can make the most impact?
I mean, definitely try to stop prioritizing things on tool by tool basis, right? One person goes there and they say, okay, from the centric queue it's there. Coming up with kind of the old school priority. Okay, is that P1 or a P2? Kind of senior engineers arguing, right? But kind of come down, rank multiple things at the same time, kind of production impact, recurrence, how recently that was changed, who really owns it. Is it easy to fix, actually, right? How likely is it has to impact something else? Was the problem clear enough from the beginning, etc.? So adding all of those things in each organization will have, then it allows you to really prioritize what's important. So getting all those together and kind of trying to get rid of those manual meetings that everybody pulls and tries to decide based on, I believe is this, or I heard that somebody complain about this, but really have all those data. So decision could be crisp with evidence, supported, and there will be no doubt in people's mind that that's what they should go for.
Yeah, let's talk about the evidence for a second. So how will an engineering manager know if they've been successful at reducing the noise and helping empower the team to make the right decisions? How will they know they're fixing the right problems?
I mean, if you're prioritizing the based on the most important things, your OKR is going to look better, right? Your customer NPS score is going to look better. You're going to have less production incidents. The backlog of things is going to be likely lower, right? Because all the easy things, you just, okay, great. That's a very quick fix and it's going to help 17 customers. Yeah, just do it, right? So that's kind of those are kind of the higher level value people get. People, we have less stress. Hopefully their white hair is going to start getting darker. I guess that doesn't happen anymore, but less white hair will be appearing on people on people's heads. There won't be They won't be sleepless nights wondering what could happen. And that's the belief. And the bottom line, I guess, I think there was data that for the Fortune 2000 companies, production incidents every year cost like 400 billion, right? So giving a big dent into that actually is pretty nice as well.
Yeah, absolutely. I mean, I think one of the hardest ones to measure, but also the most impactful, is just like, our developers happy doing their jobs, right? I see the same thing with AI tools as well. It's like, how do you know if an AI tool is working? And they've tried so many different KPIs to measure, like, was the number of pull requests, was the number of lines of code, or was it, how many things did you ship? When really, the bottom line is developers want to use those tools. I think the same is the case here, right? If developers are working on impactful work and not maintenance, right, as you were talking about before, they're going to get more fulfilled from their work, and they're going to feel more enjoyment as a result. And if you're able to somehow measure that, that tells you doing something right, I think.
Yeah, exactly.
Yeah. Boris, I really enjoyed this conversation with you today. Hopefully we have a chance to do this again. For those of you who are on with us, thank you for joining us. There's plenty more sessions for you to go explore, and we hope you enjoy your day at Sonar Summit. Thank you.
Thank you. Bye.